Math 8, Unit 5, Functions, Lesson 2, Part 1. Recognizing functions in multiple representations. Okay, remember that a relation is a set of ordered pairs. A relation can also be represented by a table, a graph, or a mapping. And sometimes an equation. This one, an equation wouldn't work. A mapping illustrates how each element in the domain is paired with an element in the range. So here I've got the same relation represented 4 times. In a set of ordered pairs, you can see the ordered pairs listed there. The table has the exact same information as the ordered pairs. They're just listed in the table. The graph is just plotting those 3 ordered pairs, and the mapping shows how 1 maps to 2, -2 maps to 3, and 0 maps to -3. The ordered pairs in the relationship there. Remember that relations in which each element of the domain is paired with exactly one element of the range are called functions. By the way, some vocabulary here. Domain is the set of inputs, and range is the set of outputs. So you'll have a function machine. If you can put an input into it, and that input only produces one output, a unique output, then it is a function. And the way to tell functions from the different representations, if you have ordered pairs or a table, you're going to do what I call the unique x test. Look at the x's. Right here, all of these x's are unique. They are all different. -9, -4, 3, 7. All unique, all different. That is a function. If we look at the not function example, as we look at these, there is a repeat. The 2 happens twice. One of the 2's go with 5, and the other 2 goes with 4. That's not a function. If you're looking at a mapping diagram, you can use the single arrow test. And as we look at the inputs here, notice that each input only has one place it can go. That is a function. If we look at the inputs here, we have an input that has 2 places it can go. That is not a function. From a graph, you use what's called the vertical line test. I can take a vertical line and pass it over my graph, and if it never crosses the graph more than once at a time, it's a function. That's a function. If I do pass it over and there is a time when it crosses the graph twice or more, then it's not a function. This is an example of a non-function. And then from an equation, there's more to it than this idea, but as 8th graders, we focus on linear functions. So as far as linear equations are concerned, if you can write it as y equals mx plus b, then it is a function. The only linear equations that are not functions are the x equals functions, because those are vertical lines, and they will fail the vertical line test. Okay. So let's look at some examples. Is this relation a function? Well, this one is, because all of the inputs only have one arrow coming out of them. Is this relation a function? Well, if you look at the x's, there is a repeat of 2. This is not a function, because 2 cannot both give an output of 1 and 4. It should only have one output. Is this relation a function? -4, 1, -1, 4, 3, -2, and -4, 5. Well, this one is no, because the input of -4 has 2 different outputs it can go with. So no, this is not a function. Is this relation a function? This one, because it is written in the form y equals mx plus b, yes, it is a function. The graph of this function looks like this. It's got a y-intercept of 3. The slope is 1. It ends up being a line just like that, and it does pass the vertical line test. Is this relation a function? Okay. If you take a look at it, no, it is not. The reason is right here. This vertical line includes 2 values from the relation. Therefore, it is not a function. The input of x equals 1 could go to either -1, that's this point, or 1 could go to 2, which is this other point. So since 1 has 2 different outputs, it is not a function. Is this relation a function? If we take our vertical line and pass it along there, does it ever cross this blue line more than once? Well, it doesn't. It does. So this is a function. It passes the vertical line test. Is this relation a function? So it's a mapping diagram. We're looking for an input that has more than one output, and this does have that 3 that goes 2 different places. So it is not a function. Is this relation a function? All right, we need to look at our inputs and see if any of them have 2 outputs. 1 only has 1 place to go, same with -2, 3, and -4. So this one is a function, yes. Okay, for this table, is it a function? Well, you need to look at the x's. We've got 2, 4, 5, and 8. They are all different. They're all unique. Yes, this is a function. Notice I haven't even paid attention to the y's. They really don't matter too much. It's about the inputs. How many places can the inputs go? Is this relation a function? Well, take a look at the x's. -9, -4, 3, 7, 6, and 3. The 3 happens more than once. One of them goes with 6, one of them goes with 2. So since 3 has 2 places it can go, this is not a function. Is this relation a function? Well, let's take our vertical line and see. I didn't make it very vertical, I guess. Yeah, that looks a little bit better. It only crosses 1 point at a time. So this one is a function. Is this relation a function? Okay, we can do the same thing where we take a vertical line and we pass it along. It only crosses 1 point at a time. It never has 2 points on it at the same time. So this one is a function. And that is it for the examples of functions and how to tell a function in various representations.